Hey guys, we are in our free online coaching classes for the JAM examination, and this video will be the lecture 5 on this series. And the topic is classification of fold, and the book which I referred is the Structural Geology by Billings. And this heading comes in the third unit, that is the Structural Geology, and we will be seeing the classification of fold only. Okay. So to begin with, the definition of fold is a fold may be defined as a curve or zigzag structure shown by a stratified rock bed, which was originally horizontal and folded due to the external force, and the probable external force is the tectonic force. Okay, so initially horizontal stratified rock formations have been bended and curved due to the external force, and such a structure will be called as the fold. Okay. And the parts of fold, the first one is the anticline, which is a upfold where the limbs dip away from each other. And that anticline is also called as the crust. And the syncline is a downfold where the limb dips towards each other. And there is also called as the trough. Whereas the limbs are those sloping sides of a fold from a crust to trough is called as a limb. Okay. So this will be an anticline which is dipping away from each other, and this will be a syncline which is dipping towards each other. And this is called as a crust, and this will be called as the trough. And the limb is a portion from this crust to trough. And the fourth one is the axial plane. It is an imaginary plane or a surface which divides the fold into two equal halves. So this is an axial plane because a plane it means it is having a length and breadth. So it divides the fold into two halves. And the next one is the hinge, which is the point of maximum curvature in a folded bed. So this is a bed. So the maximum curvature point will be this point, which is having a maximum bending, and that is called hinge. And by connecting all such a hinge point, there will form a hinge line. Okay. Next one is the plunge of the fold. The angle of inclination of fold axis with the horizontal is called as the plunge of fold. So if you can see that this hinge line is inclined to some angle, right? So this fold is called as the plunge of the fold, whereas this one is a non-plunging. Okay. So these are the few parts of fold, and let's get into the types of fold. So there are almost 27 types of fold, which you will try to cover a maximum in this video. The first one is the symmetrical fold, followed by asymmetrical fold, then overturn fold, then recombinant fold, isoclinal fold, which is having a subdivision vertical and inclined, and anticlinorium, then synclinorium, then open fold, close fold, fan fold, box fold, then chevron fold, monocline, structural terrace, drag fold, plunging fold, non-plunging fold, plunging syncline, plunging anticline, dome and basin, then doubly plunging anticline and doubly plunging syncline, antiform, synform, antiformal syncline and synformal anticline. So it seems like a big number, right? So don't worry, I will just explain it in a short for all the headings, and at the end of the video I will give you a concise picture of all this 27 in a single page, so you can just compare and remember all those folds together. Okay. So let's get into the very first type, that is a symmetrical fold. So a fold where the two limbs dip at equal angle but in opposite direction, and in this case the axial plane should be vertical and cut the fold into symmetrical half. So you can see this, the two limbs dipping away from each other, and that also in the same angle, okay, but in opposite direction, and the axial plane is vertical. So these are the essential criteria that is to be a symmetrical fold. And when you are talking about the asymmetrical fold, what happens? The two limbs dip at unequal angle. So this is a very big difference. This is dipping at equal angle, and this is unequal angle. And other things, if you see opposite direction, here it also the opposite direction. And the axial plane is here, it is vertical and it is inclined. Okay. So this is the difference between symmetrical and asymmetrical fold. So the axial plane is inclined and dipping in opposite direction, as well the unequal angle. Okay. And the third one is the overturn fold, where the two limbs dip at unequal angle and in the same direction. In this case, the axial plane is inclined. If you see these two things, you can compare that both are having unequal angle, but it is in opposite direction, but this one is the same direction, and the axial plane is inclined. That is what same it is here and there. So a overturned fold will be like this. So both the limbs dipping in the same direction. Then the next one is the recommend fold, where the two limbs dip at equal angle and in the same direction. But in the case, the axial plane is horizontal. So in my previous case, what we see is the two limbs dipping at the unequal angle in the same direction. When you are talking about the recommend fold, remember in recommend fold, two limbs dip at the same angle and in same direction. And the axial plane is horizontal. Okay. And this can also be other type, that is isoclinal fold, that is vertical, where the two limbs dip at an equal angle and in same direction, but the axial plane is vertical, right? And the third one is the isoclinal fold, which is a inclined isoclinal fold, where the two limbs dip at equal angle and in same direction, but the axial plane is inclined. So from comparing all these three, you can say the recommend fold is also called as horizontal isoclinal fold, right? But you can see the two limbs dip at equal angle. Here also the two limbs dip at equal angle. Here is also limbs dip at equal angle, and both in same direction in all the three cases. But the only difference is here the axial plane is vertical, so it is called as vertical isoclinal fold. Here it is inclined, so it is called as inclined isoclinal fold. When the axial plane is horizontal, it is called as recommend fold. Sometimes also it is called as isoclinal fold of horizontal type. Okay, is that clear? So the recommend fold is also called as isoclinal fold, but in case it is a horizontal isoclinal fold. Then the next one is the anticlinorium and synclinorium. So these are the complex fold of greater anticline and syncline forms in the case of a large anticline slash syncline with a number of secondary folds developed in it. So you can see this is an anticline and the limbs got a minor fold, so it is called as the anticlinorium. And this is a syncline and this limbs called a minor fold, so it is called as synclinorium. So in this the limb gets small minor folds on it, so it become anticlinorium and synclinorium. Okay. And the next one is the open fold. The open fold is a mild fold where limbs meet at obtuse angle and the thickness of the strata will continue or remain same. So this is a open fold. So the interlimb angle is obtuse angle. That is this portion, if you measure, this is in obtuse angle, and also the thickness of the rock formation remains same. There is no thickening and thinning. And when you're talking about the close fold, what happens? The interlimb angle will be acute. You can see here the interlimb angle is acute, and also the thickening and thinning takes place, because when there is a maximum folding out happens, the beds get thin here, and as it gets thin, the material will move in this two directions, so this two portion will be thicker. So this is called thinning and thickening. So this will take place in close fold, whereas in open fold there will be no thickening and thinning, and hence the rock formation remains with same thickness all along. Okay. And the next type is the fan fold. A fan fold is a fold in which both the limbs are overturned, and as a result what happens, the anticline dipping away from each other and the syncline will dip towards each other. You can see in this image that this is an anticline, right? In general, what you study as a definition in anticline, limbs dipping away from each other. But what happens here? This limb is dipping this side and this limb is dipping this side. So in case of anticline, what happens? The limbs dips towards each other. So such an overturning of fold will become a fan fold. Okay. And the next one is the box fold, which is a peculiar type because it has three limbs and two hinges. A box fold is one in which the crest and trough are flat, with both the syncline and anticline having three limbs and two axial planes, right? So this is a different fold from whatever we saw in earlier cases. And the next one is the chevron fold, where a fold in which both the crest and trough are sharp. So the crest as well as the trough become very sharp, angular, and such a zigzag fold is called as the chevron fold. So if you see a sharp edged fold, then it will be a chevron fold. And the next one is the monocline, a local warping in a horizontal strata is called as monocline. In this case, what happens? The rock beds lying at two levels are separated by a limb, which shows steep inclination, and such a monocline forms in vertical motion. So you can see this single rock that lies in two different levels. This is level a higher level, this is a lower level, and this has been shifted and produced a structure called monocline. Okay, mono means mono means one, cline means dipping. So dipping at only one place, that will become a monocline. And the next one is the structural terrace, which is found by a local flattening in an uniformly dipping bed. Okay, and it is called a structural terrace. In this case, the dipping strata become horizontal at a particular spot, and then they continue to follow their original dip. So what happens? This is a inclined formation, inclined bed. What happens? There is all of a sudden there is a horizontal portion in this inclined rock. So this portion is considered as the structural terrace. And the next one is a drag fold, which is a minor fold developed within a body of the incompetent bed, which are interbedded between the competent beds. What happens? The drag or impressed because the sharp indication important because the shape indicates the direction of the relative motion. Okay, so this is a competent rock which will not bend such easy, it will simply break, right? So this is a competent rock and this is a competent rock which will not bend, which will break immediately, like a hard quartz, something like that. And this is an incompetent rock which can simply and easily bend. So when what happens, when it is folding, this portion moves in this direction and this rock moves in this direction, and such a movement creates a drag effect on this incompetent rock. So what happens? This rock drags this rock, and that produces a small scale folding, which is a minor fold, that is called as a drag fold. And remember, the synclinorium anticlinorium is totally differ from this drag fold. Okay, and the next one is the plunging fold and non-plunging fold. The axis of fold may be horizontal or inclined. If the fold has an horizontal axial plane, it is called as non-plunging fold, and if the fold axial plane is inclined, then it will be a plunging fold. You can see here what happens. You can compare these two things. Here the axial plane is horizontal, and in this case what happens, the axial plane or the hinge line is inclined from the horizontal. So this one is called as a non-plunging fold, and this portion is called as a plunging fold. Okay, so this I had given this image for the comparison of these two things. So it may occur, it may not occur together. So remember, the plunging fold is one where the axial plane or the hinge line is inclined from the horizontal, and a non-plunging fold is one where the axial plane is horizontal. Okay, and the next one is the plunging syncline and the plunging anticline. So the same things happen. What happened here? It is an syncline, and it is in the axial plane is plunging, and that forms a elongate outcrop like a nose one. So this will be the plunging syncline, and this is an anticline, and the axial plane is plunging towards you, so it is an plunging anticline. Okay, so the plunging fold can be subdivided into two: the plunging syncline and plunging anticline. Okay, and the next one is the dome and basin structure. Actually, dome and basin structure, which is approximately circular or slightly elongated outcrop pattern. Dome are convex upward and basins are concave upward. The dome and basin have several origins. Compressional dome or and basin in many orogenic belt, the motion force is ascertained to the compressional responsibility of the associated force. So this is a dome structure where it looks like a upfold, right? If you see this portion, it looks like an anticline, and this portion also it looks like an anticline. Okay, so a 360-degree upfold will become a dome, right? Whereas in the basin, it is also like this. So the basin, it is dipping towards each other, like a syncline here, and if you see this side also, this will look like a syncline. So the 360-degree dipping towards each other will form a basin. And the next one is the doubly plunging anticline and syncline. You remember the plunging fold and plunging and non-plunging fold, right? When the axial plane is dipping in one direction, that will be a plunging fold. When the axial plane is dipping in two direction, then it will become a doubly plunging fold. Okay, and if it forms a syncline, then it will be a doubly plunging syncline, and if it forms an anticline, then it will be a doubly plunging anticline. Let this image be an example. You can see this is an anticline, right? And if you see this axial plane, the first half portion is dipping towards you. The axial plane is dipping towards you, and this half portion, if you see, the axial plane is dipping away from you. So the axial plane is dipping actually in two different directions, that is towards you and away from you. So this is called as doubly plunging anticline. Is that clear? If the same structure is generated in a syncline, then it will be a doubly plunging syncline. Okay, and we will do 1 2 3 4 5 6 together, so we will compare on of it is. So the first one is the antiform. So when you call antiform, a fold whose limbs close upward in a strata for the stratigraphic sequence is not known. So an antiform is like an anticline it looks, but we don't know the age of the rock, so we can simply call it as antiform. So remember, when you want to call something as an anticline, you should know the stratigraphy. Okay, the symphon is also like this. This is dipping towards each other, but we don't know the stratigraphy, so it will simply become a symphon. So an anticline is a fold generally convex upward and whose core contains the stratigraphically older rock. So if you see this one, this is an anticline. So this portion will be the core, and this portion consists of the oldest rock. So this will become an anticline. So this is an antiform with the known stratigraphy, and that is also the oldest rock in the center. That will become an anticline. The same will apply here. That is a syncline, and the core. What happens? This is the youngest rock. So if the stratigraphy is known and the center is in the youngest rock, then it will be the syncline. If you understand this four, you can simply understand these two. That is antiformal syncline. What is an antiformal syncline? You know the this is a secondary general antiformal fold on which inversion of limbs takes place. Say for example, in syncline the center is the youngest rock, but in synformal anticline you can see the center is the oldest rock. So the syncline and synformal anticline both having same structure, but stratigraphically in syncline there will be the youngest rock, in synformal anticline there will be the oldest rock. You got it? So remember, the synform means dipping towards each other, but we don't know the stratigraphy. In syncline means it is dipping towards each other, we know the stratigraphy, and the center rock will be the younger one, right? And the synformal anticline is one which is dipping towards each other, but the center rock is older one. So you can compare all these three. Synform means don't know stratigraphy. Syncline means the younger rock in the center. Synclinal antiform means older rock in the center. You got it? The same way you can compare the anticline, antiform, and antiformal syncline. Okay, is that clear? If you are clear, then it is good. If you are having some doubt, you will go through this thing. You will comparing all those folds to maximum extent in a single sheet, so you can just compare and find the difference. So we'll start from the symmetrical fold. You remember this axial plane, this is the axial plane, and the limb dip angle, okay, and the limb dip direction and the interlimb angle. Then the limbs, any properties there, they will mention the crest and trough and axis of fold. These are the main 1, 2, 3, 4, 5, 6, and these are properties which you are going to compare. So when you are talking about the symmetrical fold, what happens? The axial plane is vertical and the limb dip angle will be equal, that we saw in the earlier case, and the limb dip direction is opposite. You got it? For symmetry, vertical, equal, and opposite. If you're talking about asymmetry, the vertical become inclined, equal become unequal, only the limb dip direction will be same, it is opposite and opposite. When you're talking about overturned fold, remember the axial plane is inclined, the limb dip angle is unequal, but the only difference from this one is the dipping direction is same. Okay. When you're talking about isoclinal fold, there are three types you have earlier seen. The recommend fold is also called as the horizontal isoclinal fold, then vertical and inclined. Isoclinal means iso means same Clinar means dipping. So beds dip in same direction. You can see angle is also equal and direction is also same. The difference is when you're talking about recommend fold or horizontal isoclinal fold, the axial plane is horizontal, here it is vertical, and here it is inclined. You got it? So this is what we are comparing the isoclinal fold. Then open fold is one where the interlimb angle is obtuse, and the closed fold the interlimb angle will be acute. Okay. And in fan fold, what happens? The limbs were reversed, so the anticline will be dipping towards each other, and the syncline will be dipping away from each other. When you're talking about box fold, what happens? The axial plane there will be two axial plane. In other cases, there will be only one axial plane, right? And there will be three limbs. In other cases, if you compare, there will be two limbs only. In terms of chevron fold, what happens? The crest and trough will be the sharp. And in terms of plunging fold, you can see the axial axis of fold, the plunging what happens inclined in one direction. And in case of non-plunging fold, the axis of fold will be horizontal. In case of doubly plunging fold, what happens? The inclination in two direction. Okay. The anticlinorium and synclinorium, what happens? The limbs get folded. Okay. So this is a concise note of a few folds which we saw earlier. If you remember this table, at least you can remember many of the folds, right? Almost there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Almost you can remember 16 kind of fold in a single image. So just compare and study so you can at least remember 16 fold, and this will be very helpful for your exam, I think. I do have made the same video in Tamil and I had given the link in the description. So if you want this video in Tamil, you can check the description and watch the video. And as per your replies, most of you are interested in joining the WhatsApp group. So if you want to join the WhatsApp group for the JAM coaching classes, just mail me your name, university, class, college, etc. to my email ID. And after getting a minimum number of students, I will start the WhatsApp group. And I have grouped my videos according to the category that you can check in my playlist. You can also connect with us by mail, Facebook and Instagram, and these are the IDs. You can also support us by like, share and subscribe. Thanks for watching. Have a great day.